So far we have explored about the general purpose registers SP, LR and PC, and now let's explore special registers. Okay, so there are 1, 2, 3, 4, 5 special registers. Let's first explore the program status register. Okay, the program status register you can explore from this section here. Okay, just click that and here it is. The program status register, okay, as its name indicates, it holds the status of the current execution of the program. Okay, and this is also 32-bit wide. Here you can see 0 to 31. And the interesting thing about this register is it is actually collection of 3 different registers. Okay, here it is. The program status register combines 3 sub-registers. Okay, one is called as APSR, which stands for Application Program Status Register, which consumes only 5 bits, okay, out of these 32 bits, okay, inside the program status register. So you can interpret something like this. In the program status register, these 5 bits are called as APSR, interrupt program status register, that we call as IPSR, which actually consumes 0 to 8 bits here. So this is called as IPSR register. Okay, and the execution program status register, that we call as EPSR, and EPSR consumes some bits in between from here to here, that is from 26 to 25, 24 and some other bits in between. Okay, so this is collectively called as execution program status registers. So collectively these 3 registers are called as program status register. Okay, alright, so now what is the purpose of application program status register, that is APSR? So APSR contains all the conditional flags, okay, like negative flag, 0 flag. So this you might have studied in the basic microcontroller or microprocessor programming in order to detect the result, whether it is negative or whether it is 0 or any carry or borrow generation during arithmetic operation. Okay, you can make use of these flags. Okay, so these flags are actually part of application program register. Okay, if the current instruction execution resulted in any negative value in the ALU, then the negative flag will be set, and if the current operation results in 0 value in the ALU, the 0 flag will be set, and based on that you take decision in your assembly programming, isn't it? So these conditional flags will be useful when you do assembly level programming, where okay, you want to branch based on negative result, or you want to take some other decision on the 0 or non-zero condition. But if you are programming in high-level languages, then we just don't care about this application program status register. Okay, so if you are interested, you can always explore this document to know more about that. Okay, now let's go to the interrupt program status register. Okay, again, this actually doesn't give any useful information, at least from the perspective of our programming. Okay, so just see what they say about this register. The IPSR contains the exception type number of the current interrupt service routine. Alright, so what does that mean? It says that exception type number of the current interrupt service routine. Great, so now let's move forward to execution program status register. Okay, so in the program status register, so you can see the EPSR actually consumes some bits in between, right? So here the T bit is very important, so which we are going to discuss next. Okay, and here it is, execution program status register. So I'll just go to the T bit, okay, which is for thumb state bit. So what's the significance of this T bit of the EPSR? Actually, I have a separate video on this where I discuss importance of T bit of the EPSR, but let me explain in brief here. Okay, so as you can see here, if T bit of the EPSR is set to 1, the processor thinks that the next instruction which it is about to execute is from thumb ISA, that is thumb instruction set architecture. If T bit of the EPSR is reset, that is 0, processor thinks that the next instruction which it is about to execute is from ARM ISA. So T-bit decides whether it is ARM state instruction execution or thumb state instruction execution. So since ARM Cortex-MX supports only thumb state, for ARM Cortex-MX processors, the T-bit of the EPSR should be maintained as 1. Remember that, okay? Otherwise, execution of instruction when T-bit is 0 will result in processor fault. Okay, so we'll discuss more on this later when we discuss about T-bit with some examples. All right, so that's it for this lecture, and I will see you in the next lecture.